Hello again, this is Chris, ZL1CVD. Well, carrying on our instructions here for CatView, and I see Luciano from Italy has decided, Spain, sorry, is in the middle of making a contact here, so hopefully we won't interrupt Luciano's contact. Anyway, what we're talking about here is CatView and how we're going to set up our ALC, use it to set up ALC. Just as a recap, ALC is an important part of the transceiver system. What it does is it limits the amount of overdrive to the final amplifier. Think of it like that. So there's various ways that it can do that and various reasons that it would do that. One reason is maybe the output amplifier has high SWR. So internal to the radio, there's a feedback signal from its SWR detection system that will feed back into the driver of the power amplifier. When you get a high SWR, then it will limit the output power, thereby protecting the output transistors or FETs. Even on tube amplifiers it will protect the tubes. ALC's been around in radio for donkey's years. So if you overdrive the radio, if you're putting too much modulation audio level in, if you like, you can overdrive it and cause band splattering and signal distortion, so it's really important that you don't overdrive it. With modern computers it's very easy to adjust the level too high, and with unfortunately with the transceivers it's not all that easy sometimes to see that. One of the key features of CatView is the fact that you can see the ALC meter. When it comes up we'll show you. You can see the ALC meter at the same time as the power output, which is really important, and also being able to measure ID. So here we have ALC here, and we can see we've got hardly any ALC action happening at all. If I increase the volume level, you can see in the background there, you can see over here I've increased the volume level, and you saw that ALC shot back up. What we want to do is adjust the volume level back here on the computer output so that ALC only just starts to move. And you can see how that will affect our output level in a moment. Right, I'm going to adjust it now, and as you can see, as I'm moving the level down, ALC drops down, but my output level up here and my current remains quite steady. It'll get to a point where now, okay, we're on to another cycle, and I don't want to interrupt that. Just a minute, in another few seconds we'll be back to transmit and I'll be able to carry on my little story. Okay, here we go. Now if I keep dropping the level down, you'll see my output power drops down, and that's because modes like this FT-8 is a carrier mode, which means that it doesn't generate power until there's audio there. So the more audio they have, the more power that it will put out until it hits that ALC level in the radio that's built into the radio. And so what we're doing here is we're adjusting that audio level from the radio to ensure that we're not getting too much ALC. And what you'll notice with CatView is how reactive the bar graph is. And in fact, I think it's actually more reactive than I know the S meter on here is faster than what the S meter on the FT-891 is. So that's why I developed CatView. I wanted CatView to be easy to use, simple, portable device that would allow me to tailor my transmit, know what's happening on transmit, and know what my ALC's doing, know what compression's doing when I'm using single sideband, and to be able to easily monitor and set things. And as we can see here, you can see on the histogram, you can see as I've adjusted my power levels that the transmit levels have varied a little bit. Okay, and you'll see if the band was a bit more active, you'd also see the activity with the S meter, the green lines. Alright, well thank you for watching CatView. Leave any comments you like down below, and I'll get to them, and please like my videos. Thank you.